In this video, we're going to talk about nuclear reactions. So, nuclear reactions involve obviously the nucleus or the nuclei of atoms. And they result in particles and sometimes also electromagnetic radiation being emitted from the nucleus. There are really two main types of particles emitted. The first is alpha particles, which is actually a helium nuclei. So that consists of two protons and two neutrons. Beta particles are the other type, and they are basically electrons that are formed when a neutron turns into a proton and an electron. So this will become important as we come up with reactions that we can write for these nuclear equations. There are other types of emissions as well. So gamma rays. Gamma rays are high energy electromagnetic radiation that can accompany radioactive decay. And then there can also be other particles such as positrons, which are positively charged electrons. I know that sounds really, really weird, but they get produced when a proton is converted to a neutron in the nucleus. So we're going to mainly focus on alpha and beta particles in this particular video, but just know that there are other types of emissions possible. Now, in terms of writing out nuclear equations are written so that they balance in terms of the total mass number and the total atomic number on each side. And it's going to differ depending on if we're doing a reaction for alpha decay or beta decay. So in alpha decay, if we take this radon example here, which has an atomic number of 88 and a mass number of 226, if that undergoes alpha decay, then the alpha we create, remember, an alpha particle is two protons and two neutrons. So the mass number is going to actually go down by 4. So going from 226 down to 222. And the atomic number is going to go down by 2. Okay, so we're going to create this alpha with the 2 and the 4 particle as well. So when a nucleus undergoes alpha decay, the mass number is going to go down by 4, and the atomic number will go down by 2. And so really when you're looking at what element it's going to produce, it's going to be 2 places to the left on the periodic table. When we have a particle undergoing beta decay, then the mass number the atomic number is going to go up by 1, and the mass number is going to stay the same. And that's because we have an electron that's being formed when a neutron is turned into a proton and an electron. So the atomic number is going to go up by 1 because the atomic number is the number of protons. So the protons are going up by 1, and the element is going to be 1 place to the right in the periodic table. So we're going to form, in this particular example, carbon, and then our beta particle is written this way. So either as an electron, or you could also show it as a beta with a -1 and a 0 here. Okay, so that's it. So let's look at a couple of examples and just do those together. So we'll start with the first one. Astatine 211 can undergo alpha decay, so that's important, by emitting alpha particles. Determine the identity of the isotope formed. So we need to go to our periodic table, look up astatine, which is 211 is given here, and then if we find the atomic number, it's 85. So that's going to undergo alpha decay. So we're going to have some element here, and the atomic number is going to go down by 2, and the mass number is going to go down by 4. And then we're emitting a alpha particle, so a 4,2 alpha. Or we could also write helium here as well. So if we go and take a look for that particular element on the periodic table, that is bismuth. So this would be our completed reaction, and so we're identifying this particular isotope of bismuth here. The next example, yttrium-90 can undergo beta decay by emitting beta particles. We want to identify the isotope formed. So again, we're given the mass number here. If we look up yttrium on the periodic table, that's element number 39. And then that's going to undergo beta decay. So remember, our atomic number is going to go up by 1. And our mass number is going to stay the same. So we're going to look for that particular one on the periodic table. And then we're going to also put in our beta particle here. So we can either put it as -1, 0 with beta, or we could put that as an electron. If we go look this up on the periodic table, that is zirconium. So it's ZR. So zirconium-90 is the isotope formed. So that is alpha and beta decay, writing out nuclear reactions. That's it for this video. We'll see you in the next one.